Galaxies are vast collections of stars, gas, dust, and planets. They are the building blocks of the universe, each one unique and filled with countless wonders. They are always on the move, drifting through the cosmos at incredible speeds. Think of them like ships sailing across a giant cosmic ocean, navigating the vast expanse of space. But instead of wind, gravity is the force that guides their journey, pulling them in different directions. Gravity pulls galaxies towards each other, creating a cosmic dance that can last for eons. The closer galaxies are, the stronger the pull between them, intensifying their interaction. Sometimes this pull can lead to a spectacular event, a galactic collision where two galaxies merge. These collisions are not like car crashes, they are slow, majestic dances. They happen over billions of years, slowly transforming both galaxies involved. Galaxies are mostly empty space, so stars don't usually hit each other directly but pass by. However, the immense gravity of these collisions can have a dramatic impact, reshaping the galaxies. Our own galaxy, the Milky Way, is on a collision course with our nearest galactic neighbor, Andromeda. Don't worry though, this collision won't happen for another 4.5 billion years. Right now, Andromeda is about 2.5 million light-years away from us. That's incredibly far. But the two galaxies are moving towards each other at a speed of about 110 kilometers per second. When they do collide, it will be a slow and drawn-out process. The two galaxies will pass through each other multiple times before finally merging into one giant elliptical galaxy. Despite the name Galactic Collision, these events are more like a cosmic dance than a catastrophic crash. Stars are so spread out within galaxies that they rarely collide with each other directly. Imagine two swarms of fireflies flying towards each other on a summer night. The fireflies are like stars, and the swarms are like galaxies. The fireflies might weave around each other, but they're unlikely to bump into one another. However, the gravitational forces during a galactic collision are immense. These forces can distort the shapes of galaxies, flinging out long tails of stars and gas. Section 4, Starbursts, the aftermath of a collision. Even though individual stars don't usually collide during a galactic merger, the gas and dust within galaxies can collide spectacularly. These collisions can trigger intense bursts of star formation, known as starbursts. Imagine two clouds colliding on a humid day. The collision can cause a sudden downpour. Similarly, when gas clouds and galaxies collide, they can collapse under their own gravity, giving birth to new stars at an incredible rate. These starbursts can make emerging galaxies shine much more brightly than usual. They are a testament to the incredible power of galactic collisions. Section 5. Dark Matter's influence. Dark matter is a mysterious substance that makes up a large portion of the mass in the universe. Despite its abundance, it remains one of the greatest enigmas in modern astrophysics. It doesn't interact with light, so we can't see it directly. This makes it invisible to our telescopes and other instruments that rely on light detection. However, we know it exists because of its gravitational effects on visible matter, like stars and galaxies. These effects can be observed through phenomena such as gravitational lensing. Dark matter plays a crucial role in galactic collisions. Its presence influences the dynamics and outcomes of these cosmic events. Its gravity helps to pull galaxies together and shape how they merge. This gravitational pull is essential in the formation of larger cosmic structures. Without dark matter, galaxies might fly apart during a collision. The stability and formation of galaxies heavily depend on this unseen force. Scientists are still learning about dark matter. They use advanced simulations and observations to uncover its secrets. Studying galactic collisions can provide valuable clues about its properties and how it affects the evolution of the universe. Each discovery brings us closer to understanding this dark component of our cosmos. Section 6. The Ever-Changing Universe. Our universe is a vast and dynamic place, constantly in motion and transformation. Galactic collisions are not just isolated events. They are cosmic phenomena that play a crucial role in the grand scheme of the universe. They are a fundamental part of how the universe evolves, driving the creation of new stars and altering the course of cosmic history. Over billions of years, collisions can reshape galaxies, creating new structures and influencing the distribution of matter. These interactions can lead to the formation of entirely new galaxies. Some scientists believe that all the galaxies in a cluster might eventually merge into one giant elliptical galaxy. This would be a monumental event in the cosmic timeline. This process of merging and evolving is happening all the time throughout the cosmos. It's a continuous cycle of destruction and creation. The next time you look up at the night sky, remember that the universe is not static. It is a living, breathing entity, constantly changing and evolving. It is a dynamic and ever-changing place with galaxies constantly moving, colliding, and reshaping themselves. These interactions are a testament to the universe's incredible complexity. Our own galaxy's fate is intertwined with that of Andromeda, and their eventual merger is a reminder of the grand cosmic dance that continues to unfold all around us. This dance is a beautiful and awe-inspiring aspect of our universe.